textbook, page 324, question number 23.11. Name 4 types of ionizing radiation: alpha, beta, gamma, and X-rays. 23.12. Why are gamma rays undeflected in a magnetic field? Because gamma rays is uncharged radiation. 23.13. Which type of radiation from a radioactive source is the most highly ionizing? Alpha particles is the most ionizing radiation. What does this tell you about how easily is it absorbed? Alpha particles is the most easily absorbed radiation. Textbook, page 327. In an answer, a student wrote, the half-life of a radioactive substance is the time taken for half of the atoms in a sample to decay. What word is missing from that definition of half-life? The definition of half-life is the half-life of a radioactive substance is the average time taken for half of the atom in a sample to decay. The average time, not the time. 23.15. A sample of radioactive substance contains 200 undecayed atoms. How many will remain undecayed after 3 half-lives? After 1 half-life, the remaining undecayed atoms will be 100, half of 200. After 2 half-lives, 50. After 3 half-lives, 25. 23.16. The half-life of radioisotope X is 10 days. A sample gives an initial count rate of 440 count per second. What will be the count rate after 30 days? 30 days, how many half-life? 1 half-life is 10 days. So 30 days is 3 half-lives. After 1 half-lives, 440 will be 220. After 2 half-lives, 110. After 3 half-lives, 55. 23.17. Radioisotope Y has a half-life of 2000 years. How long will it take the activity of a sample of Y to decrease to 1/8 of its initial value? Here I need to know how many half-lives. 1/8 is which half-life? Okay, the first half-life, the sample decayed to half. After 2 half-life, I will get a quarter of atoms. After 3 half-life, I will get 1/8 of the atoms. 1/8 is half quarter, and quarter is half the half. So 3 half-lives. I need 3 half-lives to reach 1/8 of the value. 1 half-life is 2000 years, so 3 half-lives is 6000 years. Uses of radioisotopes. We can use the radioisotopes in many sections. Number 1, related to penetrating power. We use alpha radiation in the smoke detector. This is a type of devices used as a security system to detect smoke in our houses, in public buildings like hotels. Thickness measurements. In paper manufacturers, for example, they use beta radiation to check the thickness for sheets of papers to be sure that all the sheets of papers has the same thickness. Medical diagnosis. We can use gamma radiation to detect any problem in a patient's body. Fault detecting. Engineers use gamma radiation to detect any faults in metal pipes, as gamma radiation has the ability of penetrating metals. Number two, related to cell damage, radiation therapy. We can use gamma radiation to cure cancer. Gamma radiation can destroy the bad cells in the patient's body. Food irradiation. This is a way of preserving food. We can use gamma radiation to kill microbes and bacteria and preserve food. Sterilization. We use also gamma radiation to be sure that the medical equipment free from bacteria and microbes. Related to detectability, radioactive tracing. Engineers use gamma radiation to trace the movement of water underground, as gamma radiation has a power of penetrating the metals and concrete. Radioactive labeling and fingerprinting. We can use gamma radiation to show up the pattern of a genetic fingerprint. Related to radioactive decay, radiocarbon dating. We can use this radiation to discover how old objects and materials are. Thank you, grade 9 students. We're done with our book for this academic year. This is Miss Rasha. Wish you all the best.